Okay, so first of all, thank you, Daniel, for inviting me. I mean, it's a lot of fun so far, and I hope to continue along the same line. The talk is titled "Logic for Normative Supervenience." So I will offer to you a couple of advices from a logical perspective for addressing the question of supervenience. The particular normative supervenience. I must say that I don't have a lot of things to say to professional scholars in supervenience, but I think it's logic could be employed in a very profitable way in order to highlight ideas, formal features of the idea of supervenience. So that's my approach. So if you approach supervenience from a logical point of view, you start with the idea that there is not just a single logic, but there are logics. And well, the approach of logicians when they try to address philosophical problems is the following: create your own logical system to capture your philosophical intuition and check whether its conclusion and properties are reasonable in your theory. So logic is very flexible. You can change things, right? You can adjust things in order to fit your philosophical perspective. So there is no unique logic. There are many logics, right? This is an important premise because basically in the talk I will show that supervenience can be captured by using and can be represented by using different types of logics, and that some difficulties for explaining supervenience and normative supervenience, particularly in terms of logic, depends on a very narrow view of what logic is, right? A typical example is the relation in the literature between supervenience and logical entailment, right? Quite correctly, logical entailment is different from supervenience. In general, Brian, for example, in his writings, explained very well why they are different, despite the fact that supervenience and logical entailment share some properties, right? For example, reflexivity, transitivity, non-symmetry, okay, like logical entailment. But as in the literature, you find a number of views about that, saying that if you take two set of properties A and B, you may have situations where entailment doesn't suffice for supervenience. There are cases where A entails B, but A does not supervene on B. And the other way around, you have that supervenience. There are cases where supervenience doesn't suffice for entailment. There are cases where A supervenes on B, but B doesn't imply A. Right? This is plain obvious. There are a number of examples you can offer to distinguish between the one side logical entailment, on the other side supervenience. This is absolutely indisputable to my mind. But the point is that this view depends on an idea of entailment which is based on classical logic, right? So the logic we study when we start attending courses in a university, first order logic, right? Or Boolean logic. That's the idea from which we can distinguish. We must distinguish between supervenience and entailment, and a fortiori between normative supervenience and entailment. But there are other possible ways for characterizing the notion of entailment. For example, Lloyd Amberstone, in a very nice paper of 1993, and then he reframed things in a more recent paper in 2002, explains that there are two big families of logical entailments. The logical entailment called consequence relation inference determined by a set of valuations, and consequence relation supervenience determined by a set of valuations. The difference is the following. Let's take V as a set of valuations, so a set of ways for evaluating sentences in your logic. Then you have a classical logic entailment, where you have that gamma, and gamma is a set of propositions made through A, when for all evaluation in V and all elements of gamma, whenever B is true, then A is true as well. Okay, so A is entailed by a set gamma of premises. This is a standard way of characterizing entailment in classical logic, right? But Lloyd Armstrong said that this is not the only way for characterizing entailment. You may have another way, which is for Lloyd, supervenience determined by a set of evaluations. And in that sense, A is entailed by a set gamma of premises when for any pair of evaluations V and Z in V, and all elements B in gamma, if V and Z converge in evaluating B, then they converge in evaluating A, right? So this is in essence the idea of determination of supervenience, right? Lloyd Armstrong in the paper has shown that this type of consequence relation is a consequence relation in a technical sense, so give rise to logical systems, families of logical systems. So insofar as you may have a different idea of entailment, you can avoid the objections that logical entailment and supervenience are different things, right? And if you succeed in that project, then you have a good tool in your hands. You have a logic suitable for modeling supervenience as a type of relation, right? So basically, in my talk, I will follow this line, right? Okay, my approach is that if you have questions, you can just interrupt me whenever you want. Okay, usually I think it's more instructive, you know, and I think it, you know, if you don't understand something, if I say something is not convincing to you, just raise the hand and say, you know, this is bullshit, you know, no problem. Okay? Okay, but this is the route I will going to take. Then the question is supervenience and normativity, because I will not give a talk about supervenience in general. I will give a talk about supervenience and normativity using logics, right? Well, this is just a definition, you know. Let's start with this definition. It's very sloppy, I know, just to understand, right? Supervenience and normativity is that we have normative supervenience, but you know, I will make a distinction later. So, is a binary relation between properties such that normative properties of a kind A supervene on non-normative properties of kind B. I know this is problematic. You know, Danielle, you know, quite rightly pointed out yesterday that, you know, when you speak about normative properties, then you're in trouble. You have to show that they exist. I don't care. You know, I'm a logician. I'm not now working on this stuff, right? And just, so, you know, let's start with that, right? Okay, so when you have to do with that, you may have two types of moves. Logicians may work on using two types of moves. The first move is to see that there is a way for characterizing the normative supervenience in terms of supervenience of the normative. So, which is basically what is described here. I have non-normative properties, I have normative properties, and the supervenience is a bridge connecting non-normative to normative properties. But what makes the supervenience normative is the fact that we have normative properties, right? So pictorially, we have something like that, right? We have two sets of properties. We have non-normative properties and we have normative properties, and then supervenience is something that magically connects the two domains, right? This is an approach that I call supervenience of the normative, but there is another way of proceeding, right? Where basically we have two domains. We have a domain of non-normative properties, and we have a domain of properties. I don't know whether they are normative or non-normative. I don't care. The fact that they are normative depends on the fact that there is a normative bridge. It's the normative bridge that connecting the two domains makes those properties normative, right? So, if this is the approach, then we must explain what is this arrow. What properties are enjoyed by that arrow? My approach is, well, if you speak with logicians, they of course prefer this. Why? Because we have to do something. Because if you ask a logician, you know, do the previous approach. That's ridiculous, you know. We take for granted that there are normative properties and non-normative properties. We have a two-sort of language. Let's distinguish predicates and relation in two sets. Normative, the set of normative predicates and the set of non-normative predicates. And then you simply connect them. But if you want to make a logician happy, you must work in this way. Why? Because this is a way for logicians to say, look, I will give you some special formal properties for a relation called normative supervenience, right? Otherwise, you know, the alternative is that you have two types of properties, and supervenience is a metaphysical relation, right? Not a normative relation, okay? So this is basically what I'm trying to do here, okay? Is it clear? Right. So that's the basic move I wanted to take. Normative supervenience is a logical entailment that makes properties normative and that correspond to ways for identifying the set of normative possible words. Right? If you are a deontic logician, you are working in model logic for practical reasoning. It's quite clear in your view that you have different types of necessity. You have alethic necessity, which can be logical necessity, metaphysical necessity, whatever. Then you have normative necessity. You have epistemic necessity. You have temporal necessity. You know, you may employ the machinery of model logic for characterizing relation among possible words. And different types of relations qualify words in a different way. They define different domains of possible words. If you are operating within the set of normative possible words, you're working on the idea of ideality. And when you work on possible words, you are saying that possible words are ideal words from a certain point of view. Right? That's the reason why it's much more intriguing for logicians to work in this direction, because it's quite obvious from a technical point of view that in order to characterize the link, the arrow, you'd work on how a world is connected to other words in a normative sense. Right? Okay, so the layout is the following. So I will give you the assumptions and then a couple of, briefly the layout, and I proceed. So the assumption is that the formal aspects of supervenience can be captured by a suitable form of entailment. If you don't like this idea, you can leave now. And the second point is that supervenience-based entailment is modeled as a normative supervenience and not as supervenience of the normative. Okay? So I will avoid any metaphysical issue. Okay? And I will tell you two stories. The first story is a story about count-as relation, institutional supervenience, from John Searle. And the second story is about model logic for jumping on generated and normative. Okay? So I work on different levels. The count-as connection is very concrete level for explaining how the normative supervenience works. The second level is much more abstract, right? So I will explain what type of modalities can be employed in standard definition of strong and weak supervenience. So I'm trying to align to a very well-established debate, right? Okay, story one, count-as relations. Okay, second I drink. Count-as relation. So what's is a count-as relation type of supervenience? So I give you a couple of definitions and some examples. One definition given by Searle in 1995 is that count-as relation assigns a status y to x, and with it a function that x does not already have before just in virtue of its being x. This piece of paper counts as money, right? The property of being money is an institutional property that supervenes on the brute fact, corresponding to this piece of paper, right? Another definition is the following, which gives more intuition how the count-as link works. Count-as relation has the following canonical form: x count as y in the context C, where typically, as I said, X denotes a brute fact and Y an institutional fact. Okay? You can, of course, see the conditional structure, right? The entailment structure in this type of connection, right? It seems to be that, if you take a look in the literature, that this idea recalls in a convincing perspective that the idea of supervenience, right? There's a type of determination, and there is a type of non-reducibility. Okay. But this is just a very rough idea, right? So we have to be more precise, right? What type of determination we have, what type of non-reducibility we have, what properties are enjoyed by this relation, right? And consider the following example, okay? Which is my running example for explaining a couple of properties for count-as relations. Electronic signature or digital signature counts as handwritten signature in the context of Italian contract law, right? It's a very concrete example. We work on that. I work with that every day when I sign my my report for my university. I use my card as a signature, a digital signature. Yeah, fantastic, right? But is it a case of, is it a good example for illustrating the idea of normative supervenience? Is it a case, that points out that count-as relation is a type of normative supervenience? Yes and no, right? Why? So let's consider all possible combinations, let's work on on the definition of weak supervenience. So let's work on a single possible word, okay? So E sign means electronic signature and H sign means handwritten signature, right? Okay, is it okay this case? Do you feel good? Is aligned to the idea that electronic signatures count as count as handwritten signature. Is it corresponding to the idea that electronic signature supervenes on handwritten signature, the property of being handwritten signature, somehow supervenes on the fact that it's electronic signature? Do you like this? I mean, does it violate the requirements for supervenience? No, we just have that. We have the covariance, right? We just have that. Given two individuals, they are both. They are both electronic signature and handwritten signature in some sense, right? Okay, so this is a case which doesn't offer any problem, right? The same here, right? I have handwritten signatures. They are not electronic signatures. Okay, no problem at all. This doesn't show that we don't have supervenience. This as well. Okay. The cases are interesting are this one. So here we have a problem, right? Because we have that one individual is an electronic signature, the other is not electronic signature, but they are both a handwritten signature. So can you accommodate this in the context? My reasoning is not technical. It's just I resort on your common sense intuition, right? How can you accommodate this situation, right? When do you have that? You have handwritten signature without being an electronic signature. The only case where you have that is when you have an handwritten signature. That's it. So this case corresponds to, if you want to consider this case, you should assume that handwritten signature counts as handwritten signature. Right? And this is also another case, right? Two individuals are not electronic signature, they are not handwritten, and one is handwritten signature, the other is not. The same. When can you have an individual which is a handwritten signature without being electronic signature? In a broad sense. Only when you have handwritten signature. So you are in those cases. If suppose you're not working on a count-as relation, you're working on supervenience in general, right? You're working on properties. Those two cases show that you don't have supervenience, right? Because you don't preserve the fact that the two individuals enjoy or don't enjoy the properties, right? Covariance violated here, right? So those two cases are cases that should show that count-as conditionals are not supervenience. But in order to accept those cases as meaningful, you need to assume that the fact that handwritten signature counts as handwritten signature. So in other words, the way for acknowledging that this is a problematic case is to accept reflexivity of count-as. Well, in fact, in the literature of count-as, many argue that the count-as does not in general enjoy reflexivity, right? You know, this is an important issue because most logical systems enjoy reflexivity. You know, so A implies A holds in most logics, but not in all logics, right? In entailment, of course, like classical entailment, it's tautology, right? So nobody objected about that, right? But in order to accommodate that case, you just need to give up reflexivity. If reflexivity doesn't occur, then you're no longer in trouble. And in fact, many logicians who are working on a count-as relation exclude that reflexivity is the case. Notice that Andrew Jones and Marek Sergot in 1996 argued that count-as relation capture what is called conventional generation by Alvin Goldman, book of 1970, A Theory of Human Action, right? When he speaks about conventional generation, right? Conventional generation resembles a lot to causal relations. And in fact, despite the fact that David Lewis in Counterfactuals argued that conditional capturing causal dependence are reflexive, many other logicians, for example, Yves Chohan, but following Patrick Suppers, said that the causal dependence doesn't enjoy reflexivity. So if you want to model a generative relation where you have a dynamic relation, when you have the antecedent determines the occurrence of the consequent in a dynamic sense, reflexivity must be abandoned, right? So insofar as count-as conditional captures some kind of dynamic generation, right? Reflexivity can be abandoned. In my case, should. Yeah. So this is my working up. But at the end in a couple of slides, I will give you a couple of options, right? Right? In my case, well, if you are canonically, if you want to follow canonically the idea of supervenience, according to which you must guarantee, in a strong sense, covariance, reflexivity should be abandoned, right? So, in this perspective, the count-as is a normative supervenience and is a generative what? What's that? I have no idea. Okay, is a generative dynamic relation. But it's not finished. Another quite indisputable property of a logical entailment is transitivity. You know, if A implies B and B implies C, then A implies C, right? Look, there are two different arrows. Double arrow is the count-as relation, and the single arrow is just classical implication, right? This is an axiom schema, right? Well, in many works, including my own works, full transitivity is not suitable for countess connections, right? This is an example, and this is very instructive. Electronic signature count as handwritten signature. Handwritten signature count as handwritten evidence. But of course, electronic signature doesn't count as handwritten evidence. So here you don't have full transitivity. The question is a question for you. Why we don't have transitivity here? Make a guess. I give you another example, which is not about based on countess, but is based on causal dependence, because also causal dependence for Shoham doesn't enjoy full transitivity. Removing a car's engine makes the car lighter. Making the car lighter increases its speed, but removing a car's engine doesn't increase its speed. So what is behind this example? Why you cannot chain conditionals? Because there is something implicit, right, in the conditional, right? Those who work, I mean, if you are familiar with the literature on counterfactuals, for example, you know very well why this is the case. Because when you say A conditional B, the truth of A assume that there are other things that are not explicit in the antecedent, which are true as well. Okay? Removing one car makes the car lighter. Making the car lighter increases its speed, but in the second conditional, it is assumed that making the car lighter doesn't undermine the fact that the car works. Right? There is something implicit. The fact that there is something implicit makes impossible to accept full transitivity. Okay? Those who work on the countess connection say that this is obvious because countess rules don't operate in isolation, they operate in systems. Right? Others say that this is a good evidence that countess connections are defeasible. Right? They are defeasible. And this leads directly to the third question. Classical entailment enjoys the strengthening of the antecedent. A implies B, then A and C implies B. So we can add conjuncts, right, in the antecedent of conditionals. Okay? Logicians call this strengthening of antecedent, or if you work on the consequence relation, monotonicity. The point is that countess, in general, doesn't enjoy monotonicity. This is an example. Raising hand in auction, in the context of auction, count as a bid. But if I raise one hand and scratch my head, this doesn't count as a bid. Right? So when you say that raising one hand counts as a bid, you are assuming that something implicit is true or is not false, or is false, right? Another point of discussion in the literature is that it regards the strengthening of antecedent, right? My view is that countess relation doesn't enjoy in general full transitivity. Okay? If you have strengthening antecedent, that you have something else. You don't have a generative relation, you have a classificatory relation. You know, classical logic is just set theory, right? Or is a Boolean algebra. So when you say A implies B, you are saying that A is a subset of B. That's it. So when you're working on classical entailment, you're working on classifications, right? The point is that countess connection is a generative relation. It's not a classificatory relation, right? Under this assumption, is countess connection can be a type of supervenience, right? Okay, I can skip. Okay, this is the axiomatization I developed myself. A few seconds, and then I go ahead. Okay. The first axiom is a restricted version of transitivity, because it says A implies B and A and B imply C, then A implies C. Look, we can build a bridge from A to C through B. But it's not full transitivity, right? Because we need that C is implied jointly by A and B. Try to apply this schema to the example of electronic signature. You will manage, right? The opposite is a restricted version of strengthening of the antecedent. Because I add a conjunct to the antecedent, but only if A implies B and A implies C. So I need that. I need the fact that one of the two conjuncts imply the other, right? So this is not full strengthening antecedent. And the logic is closed under those rules. One important, I don't spend time to explain the rules, but what is important, I think, notice that this logic is not closed under logical implication, right? I explain you the semantics, I think, because I think it's instructive. So the semantics, I think, is instructive for understanding why the context connection is a normative relation. Because one way for giving a semantic interpretation of that link is through the idea of selection of function models. So you have a function that picks up for each formula, a subset of worlds which are the most preferred worlds with respect to that formula and the current world where you are evaluating the formula. Okay, so suppose we are evaluating a formula in W. We need to select a subset of worlds which are the most preferred worlds. They are the ideal worlds, right? So basically, we have a function that assigns a subset of worlds to the given world. And then we evaluate the conditional here. We don't work on the full set of worlds. We just pick up a subset of worlds which are taken to be the most preferred. For example, according to a certain preference relation, right? Certain ordering, okay? Okay, this is just the technicality, and I think I will skip. I just give you evaluation. So in a world here, in a world W, the context conditional is true if and only if this function, FAW, is the function picking up the most preferred worlds with respect to the world W and the formula A. And this is a subset of the set of words which are where B is true. Okay? So in other words, I'm selecting the best words with respect to A, the best words, and there I check whether those words are also B words. Right? So this is a way for explaining why context conditional is normative. It's a semantic reconstruction of the normative character of context. Of course, there are also philosophical explanations. John Searle says that, in fact, context conditional makes sense only when we have the capability of generating obligations, stuff like that. But I don't care. I mean, this is an interesting story, but I don't have time to explain that. Okay, so this is the first story. So the second story it has to do with meta theory of normative supervenience and model logic for box. Okay? So with context conditionals, I'm working on a very concrete example, right? Here I will work at a more abstract level. Okay? So which model logic? It counts. Of course it counts. Okay? I give you a couple of examples. Well, usually in the literature of now I'm working on general idea of supervenience, not on a normative supervenience, right? And just a couple of examples, general examples, right? In the literature, there is a discussion about the fact that is there any difference between quantify all over possible words and using box, using necessity operator? Usually they are taken to be different. But there is no right answer. Depends on what type of logic you have for box, right? For example, if your logic is S5, which is in most works taken to be the logic for metaphysical necessity, then it's true that there is no difference between quantification of a world and box. Why? Because in S5, you have those action schemata, distribution of necessity over implication, reflexivity. So if A is necessary, then A. The iteration of necessity. If A is necessary, then is necessary, that is necessary. A. And if A is possible, the diamond means possibility. If A is possible, then is necessary, that is possible. Right? From the semantic point of view, this logic corresponds to an accessibility relation. So you have an arrow connecting worlds, which is reflexive, transitive, and symmetric. So you have an equivalence class, right? So basically you have a set of all worlds, and you can travel from one world to another world without any connection. It's called also universal modality, because it doesn't matter. You don't need arrows, right? You are in a world, fair enough. You can jump in any other worlds. No, there is no limit. It's called universal modality. Universal modality because, in fact, working on cluster of classes of equivalence of worlds is nothing but quantifying all the worlds without any restriction. So if you have that type of modality, you know, the question, from a logical point of view, the distinction between quantifying all the worlds and using a box is pointless. Perhaps philosophically interesting, but from a logical point of view, is pointless, right? Another example where we're showing that it counts, you know, Bacon in a paper from 1986, you know, was claimed that weak supervenience entails strong supervenience, right? The assumption was that, you know, what he called diagonal closure. It's not important to spend time here. But I think the interesting point is that for developing the argument, weak supervenience entails strong supervenience, he assumed that box corresponds to S4, which is S5 minus schema 5, right? Schema 5 says if it's possible, then it's necessarily possible, right? S4 is taken to be a weaker version of metaphysical necessity, right? So, you know, you just drop, you know, an action schema, everything changes, right? A third example is Wedgwood. In the book of 2007, Normativity, he gives up the schema 4. So, you know, he says, you know, this is a schema is wrong, doesn't work, I don't like. You know, I'm not interested in recalling the argument. I don't remember, by the way, but I remember that he gave up schema 4, which, by the way, blocks Bacon argument. Because without 4, it's not possible to show that weak supervenience implies strong supervenience, right? So model logic counts. You cannot speak about worlds. You must have clear in mind what worlds you work on, and what is the way in which you manipulate possible worlds, right? Okay, so sorry, this is a bit technical, but it's nothing but a standard rephrase of standard definitions of strong supervenience and weak supervenience. The only difference is that there is no quantification over predicates. Logicians don't like second-order logic, but we don't need it. Only if there is a guy with a gun saying use second-order logic. But if you can skip it, it's better to avoid it for a number of reasons. And in fact, in the definition of supervenience, you don't need it. Because, you know, quantification, universal quantification is nothing but a big conjunction. And existential quantification is nothing but a big disjunction. So these are a more canonical way of writing weak supervenience and strong supervenience, right? Assuming that we work on model operators, of course. Okay? Big conjunction. It means that for all properties in the set A, assuming that the set A is closed under some properties. I don't care what properties we use. There's a lot of literature on that, but I'm not involved in this talk on that. AJX implies that there exists a property, at least one property in B, blah, blah, blah. And then the standard definition of supervenience, weak supervenience. And then the strong definition of strong supervenience. The only difference, as you can see, is that in the weak definition, we have a box. Here we have a box outside and a box here. Okay? It's very standard. Okay? So, given those definitions, very standard, you know, it counts a lot whether you have a certain model logic or not. For example, assume you have T. T is a logic where you just have necessity A implies A. Assuming that you have domains of individuals that don't change across possible words is another important issue, right? Which is overlooked in the literature. We speak about individuals. You want to have constant domains, increasing domains, decreasing domains, varying domains. You know, in the literature of 70s, logicians and philosophers took were very careful in saying, look, I have possible words. Each possible word is equipped with a set of a domain of individuals. The set of individuals is constant across worlds. You know, in the literature of that time, and I agree with that. I like this very much. Quantified model logic, when you have constant domain, means that you are working on a very strong idea of metaphysical necessity, right? So if you have a very strong idea of metaphysical necessity, that's the idea. S5 plus constant domains. But you know, we work on a weaker version, just T. When you have just T, well, we discover that you can instantiate the formula weak supervenience to a couple of individuals and remove the box. All right? So this is something you obtain. It's not obvious to my mind that you can do that. But if you have T and you have constant domains, you can do it. Or if you assume even a weaker version of the logic, which is called K, you have constant domains, then you can have this. You can distribute the box inside the formula. You say that weak supervenience implies that if B enjoys a certain property AJ necessarily, then B enjoys a certain property necessarily, and double necessity of the implication in the antecedent and the consequent is not obvious to my mind. But this is a trivial deduction in model logic. It's just a matter of two steps. Okay? Other two final comments, and then I speed up to the end. You know, if we have constant domains, we have this. You know, we have Barkhan formula and converse Barkhan formula. So basically, the Re and the Dicto formulas are equivalent. And if you have Barkhan formula and converse Barkhan formula, means for all x, box A, and implies box for all x, AX, and vice versa. In S5, you can remove, you have a very strong result proved by the end of 70s by Kit Fine. The Re formula is equivalent to a de Dicto formula, and vice versa. So I can rephrase strong supervenience, putting the box within the scope of the quantifier. You know, this is from a metaphysical point of view, has a lot of implications, right? So it's just a matter of what logical assumptions you have. So, but all this stuff makes sense to normative supervenience? No, it doesn't make sense. So those logics are tremendously strong. They are wonderful for metaphysical necessity, but if you want to work on the old, they are too strong. Okay? Okay, so if we jump into practical necessity, we have something like that. So we have weak supervenience, strong supervenience, but here we no longer have analytic necessity. We no longer have metaphysical necessity. We have deontic necessity. In other words, the interpretation is the following. In all ideal worlds, a certain covariance relation holds. Right? It's not a matter of checking whether you have these co-occurrence of properties in the space of metaphysical worlds, metaphysical necessity, but we have to confine ourselves to the set of ideal worlds according to a certain preference relation. Right? So we are working in a different logical space. Right? So what type of logic we need for the oath that connects properties? Well, this means engaging in the history of deontic logic, right? But there are some indisputable schemata that are accepted by almost 90% of logicians, and they are okay for normative supervenience as well. The first is, okay, this is a paradox. Okay, I show you the paradox just to explain why we give up a couple of properties. This paradox is famous. A paradox called the paradox of gentle murderer. Deontic logicians like to work with paradoxes. So suppose you have the prohibition to kill, but if you kill, you're obliged to kill gently. And suppose you have a fact that you kill. Right? In logics like the logic we saw for metaphysical necessity, we have this schema. Right? If A implies B is a logical entailment, a classical logical entailment, then if it's obligatory A, then it's obligatory B. Or is optimal A, then is optimal B. You can read out as you like. Right? Since kill kill gently implies kill, if you have to kill gently, then you're obliged to kill. Right? This is just a trivial step, logical step, right? From 2 and 3, we derive that since I killed, then I should have to kill gently. From 4 and 5, I derive that I have to kill. But the problem is that I had the obligation not to kill. So I'm in contradiction. The contradiction depends on the fact that the logic is closed under logical implication. That's the reason why classical implication doesn't work. Right? There are other paradoxes. One is a Good Samaritan paradox. Right? There are a number of other paradoxes. That depends on the fact that the oath is usually taken to be closed under logical implication. Right? But if you drop logical implication, that's everything is more or less solved. There are other problems, but some indisputable axioms are this. The consistency of oath, if A is optimal, is desirable, is the most preferred, is obligatory, depends on your idea of normativity, right? Then not oath, not A. Other two axiom schemata are that the oath cannot have in its scope a contradiction. You cannot say something impossible is obligatory. But also, you cannot say that something tautological is obligatory. How can, because does it make sense to say, please violate this obligation? It's obligatory that today it's raining and it's not, or it's not raining. Can you violate this obligation? There is a state of the world where you don't comply with the obligation. No, there is no There is no way of violating the obligation, right? So it doesn't make sense to state that something tautologically is obligatory. But this is obligatory. Box T is one of the basic axiom schemata for metaphysical necessity. Right? It's obvious that if something is a tautology, it holds in all worlds. Must hold in all worlds, right? Well, this doesn't apply to normativity. Because normativity requires that you must be able to violate norms. Otherwise, it doesn't make sense. right? And the logic can be only be closed on the logical equivalence. So if A implies B and B implies A, then you can have a closure, right? But you cannot close the system by logical implication. Two slides and it's finished. So the semantics for the oath here is very instructive to my mind. I give just the intuition, then I stop, I promise. It's based on two perspectives. The first perspective is that we have a plurality of worlds. Okay, so we have possibly an infinite set of worlds, standard. But this set of worlds is a subset of the logical space of metaphysical necessity. I'm not working on the whole set, only on a subset of that, right? And then for the type of logic I have just shown, very, very simple, we have a plurality of accessibility relations. You know, if you are familiar with Kripke semantics, you know, in model logic, you just have worlds and you have a relation connecting worlds, right? And you say something is necessary in a world if necessity A is true in a given world, if and only if A is true in all accessible worlds through a certain accessibility relation, right? Here we have not just a single accessibility relation, we have possibly an infinite set of relations. Philosophically, they can be explained in terms of different codes, different legislations. You know, Carla was mentioning yesterday about different types of legislations. But you don't need to commit yourself to any thick idea of normativity. You could, as some do, interpret different relations as personal subjective preference orderings. You know, a relation just corresponds to a subset of most preferred words according to my own preferences. Okay, so there is no philosophical commitment in this formalism. If you like to interpret a relation in terms of rational legislations, fine. If you want to interpret that in a very basic sense as just a preference utilitarianism, fine. You just interpret relations as preference orderings, picking up set of words desirable from a certain point of view. So the interpretation that oath A is true in a given world in W here is not true, because we have two relations, the arrow relation, the red relation, the blue relation. There is no relation pointing to a subset of words where A is true. Each relation, each code, suppose there are two moral codes, right? The Italian moral code and the German moral code, right? In Germany, A is not desirable in all cases, but also in Italy. So there is no way for making true the oath. But if there is at least one relation, one code, then oath is true. Okay? So the semantics works in this way. The oath is true in a given world if and only if there exists a relation, a standard, the ontic standard that picks up the subset of most preferred words according to that standard, and in those words selected by that arrow, A is true. Right? Okay, this is the semantic. I think I skip it, the details, and then I stop. Conclusion. So normative supervenience versus supervenience of the normatives. Well, in essence, the distinction is the following. Selecting the ideal words where properties hold versus selecting normative properties hold in all possible words. The normative, the supervenience of the normative is a way where you basically, from a logical point of view, use 59. No, basically, you work on this entire space of possible words, and then you look at the words and you try to find normative properties there. The other approach is normative supervenience in terms of selecting the ideal words where properties hold. And the very fact that they are holding in normative words, they are normative properties. Right? The fact that they are taken to be ideal, the most preferred, makes them normative. Right? A second view is that, a second point that I think, second conclusion, that normative supervenience can be analyzed in terms of suitable consequence relation and non-classical entailments. That I think is a good achievement, I think. Counter is an interesting type of normative supervenience. Is a sui generis, I think, but I think is instructive for many reasons, because there are good remarks regarding transitivity, reflexivity, and other properties. And another conclusion, that model logic for the oath change the formal behavior of standard definition of weak and strong supervenience. Many obvious results you have from the most standard definition of supervenience are not, must not be taken for granted if you change the model logic. And from the oath, the model logic cannot be S5, cannot be S4, cannot be T, cannot be K, must be weaker, right? And that makes very interesting investigating the logical nature of supervenience, normative supervenience, to my mind. Okay, that's it. Thank you.